Hello everyone, for this video we will discuss the voltage divider rule. We have this circuit with a voltage source labeled as V and two resistors, R1 and R2 connected in series. The values of the components are also specified in the circuit. The voltage across R1 is designated as VR1, and at R2 is designated as VR2. The current flowing to the circuit will be denoted as I. Remember that in a series circuit, the current is the same all throughout the circuit. To use the voltage divider rule in this circuit, first we have to know that VR1 is equal to the total current I, multiplied by R1. But it is equal to V all over the total resistance of two series connected resistors, R1 plus R2. The value of I can be substituted here in this equation. So VR1 is equal to V all over R1 plus R2 multiplied by R1. Simplifying the equation, it is equal to V times R1 all over R1 plus R2. VR2 is equal to I times R2. Again substitute value of I. It is equal to V all over R1 plus R2 times R2. VR2 will become V times R2 all over R1 plus R2. We can now use the given values. VR1 is equal to 20 times 5, all over 5 plus 10. 20 times 5 will be 100. 5 plus 10 will be 15. It will be 100 over 15. This will result in 6.67 volts. Then VR2, it is equal to 20 times 10, all over 5 plus 10. 20 multiplied by 10 is 200. 5 plus 10 will be 15. So, 200 over 15. This will be equal to 13.33 volts. Remember guys, that the sum of voltage drops will be equal to voltage source. So if you add VR1 plus VR2, it is equal to 20 volts, which is equivalent to the total voltage, V. Meaning our answers are correct. Here is another example. A voltage source labeled as V and it's connected in series with three resistors, R1, R2 and R3. Their values are also given in the circuit. Okay. Let's designate the voltage across the resistors as VR1, VR2 and VR3. Then we labeled the total current flowing as I. Just like the first example. VR1 is equal to I times R1. But I is equal to V all over the total resistance of the three resistors connected in series. R1 plus R2 plus R3. Then substitute it to the first equation. So, VR1 is equal to V all over R1 plus R2 plus R3 multiplied by R1. Or simply, it is equal to V times R1, all over R1 plus R2 plus R3. So it follows that VR2 is equal to V times R2, all over R1 plus R2 plus R3. Then VR3 is equal to V times R3, all over R1 plus R2 plus R3. Now, we substitute the given values. For VR1, it is equal to 15 times 2, all over 2 plus 4 plus 8. 30 over 14. This will result in 2.14 volts. VR2 is equal to 15 times 4, all over 14. 60 over 14. The answer is 4.29 volts. Lastly, VR3, it is equal to 15 times 8, all over 14. 120 over 14. Then, the answer is 8.57 volts. Then again, to check if your answer is correct, add the three voltage drops, VR1 plus VR2 plus VR3. 2.15 plus 4.49 plus 8.57 is equivalent to 15 volts. So our answers are correct. So that's it, guys. That's how to use voltage divider rule. Thanks for tuning in to today's video on the voltage divider rule. If you found this explanation helpful in understanding how to calculate voltage across each resistor, don't forget to hit the like button and subscribe for more insightful content. Feel free to drop any questions or topics you'd like me to cover in future videos in the comments below. Until next time, happy learning and experimenting in the world of electronics.